So, I'm recording. So we have cos. Okay, we need a marker. That's okay. We have cos squared x. Shh. Quiet, please. Cotan x sine x. And then we have cos squared x equals cos x over sine x times sine x. So we know we're going to get restrictions, and I said solve it between 0 and 360. And then state NPVs. So we're going to get restrictions for this sine x because it's in the denominator. So I have to find all the spots where sine x equals 0, between 0 and 360, and kick it out because it can't equal 0. So sine is when y equals 0. So it'd be 0, 180, and then 360. And we would include all of them because what? What does my domain have? Equal to. So 0 and 360 are included. Sometimes one side has it and one side doesn't, so you have to watch yourself. Okay? So x can't equal 0, 180, and 360 are my restrictions. So if any of those pop up, I have to say they're extraneous. So now the sine x's can cancel off because they actually cancel. Now some people here will say, well, I can divide the cos x over. Remember, whenever we want to make the equation equal to 0, we never divide over. We subtract over so we don't lose half our solutions. So we're going to get cos squared x minus cos x equals 0. Take out a cos x. And then I'm left with cos x minus 1. I get cos x equals 0. Cos x minus 1 equals 0. Cos x equals 1. So cos x equals 0 when x is 0, which is here and here. So x equals 90 degrees and 270 degrees. And both of those are good. And then cos x equals 1 is where what? Where x equals 1, which is here. And so that's at 0 and 360. But what's the problem with 0 and 360?
Sine is 0.
And it's simple that it's extraneous. Okay? Did everyone get that? Yeah, what?
Do you have to say the extraneous part?
Yeah. You'd say extraneous because they were a solution, but they can't happen. So when I wrote this, you get a solution that can't happen, it's extraneous. All right. So remember, whenever you get a solution that can't happen, it's extraneous. So we kick that out. So 90 and 270 are our answers. Okay, new question. Algebraically solve 2 sine x equals 7 minus 3 cosecant x. General solution. In degrees. When you're done that, I want you to solve sine 2x equals root 2 cos x. General solution, radians. So, okay, so we have 2 sine x equals 7 over 3 over sine x, which once again we have that problem. Sine x can't equal 0. Where does it equal 0? Here and here. So our general solution for that would be x can't equal 0 degrees plus 180 degrees and NEI. Do I need the 0? Nah. So I go x can't equal 180 degrees and NEI. All right. Then multiply by sine x. We want to get rid of the fraction. So we get 2 sine squared x equals 7 sine x minus 3. Move everything to one side. 2 sine squared x minus 7 sine x plus 3 equals 0. Let m equal sine x. Or you can leave them if you can work with them. 2m squared minus 7m plus 3 equals 0. And so we get what times what equals 6. What plus what equals negative 7, negative 6, negative 1. So we get 2m squared minus 1m minus 6m plus 3 equals 0. Group. Take out an m. 2m minus 1 minus, minus 3. 2m minus 1. So I get m minus 3 equals 0. 2m minus 1 equals 0. M equals 3. M equals a half. M is sine x. Sine x equals 3. Sine x equals a half. Now, I told you if it's sine or cos, not cotan, not cosecant, not secant, not tan. If it is sine x, then I said to you, it can't be what?
More than 1.
Or? Less than negative 1, because your graph mins at negative 1 and maxes at 1, right? So we technically have a sine graph right now going like this. This is 1, this is negative 1, and then we have a horizontal line at 3. So are they crossing? So some people will say it's extraneous. No. Extraneous is I got a solution, it didn't work. It was a restriction, or I plugged it in and left side didn't equal right side. That's extraneous, right? This actually creates no solution, right? Not extraneous. There's just no solution. And no solution means if I put it into y1 and y2 in my calculator, it wouldn't cross anywhere. Okay? Then this one, sine x equals a half, which is here and here, which is 30 and 150. Are any of those my restrictions? No. So I say x equals 30 degrees plus 360 degrees n, NEI. And then x equals 150 degrees plus 360 degrees and NEI. Yeah. True that. Did everyone do the other one? Okay, I'm just going to rewrite on another page because this thing doesn't extend. I love how the upgrade. Ah! I must have not upgraded this one. It's still the old smart. Hello, little extend page. I love you. Didn't know I loved you till I got taken away. You know, like you sometimes don't realize you should really love something until it's taken away. That's the extend page on Smart Notebook. Okay, so sine 2x is 2 sine x cos x. Shh. Equals root 2 cos x. Never divide. We always subtract to get it over to the other side. Now, if this is confusing to you, I told you could say let m equal sine x and let n equal cos x, right? Or if you can see that both of these have a cos x involved, I can GCF out a cos x, and I'm left with 2 sine x minus root 2 equals 0. And then I get cos x equals 0. 2 sine x minus root 2 equals 0. 2 sine x equals root 2. Sine x equals root 2 over 2. So cos x equals 0 when x equals 0. I don't know what's going on. I love this bush. Okay. So cos x equals 0 here and here, which is pi and 3 pi over 2. So in radians, we always look back and make sure we're using the right variable, because some of you will still write thetas. You really like, today no one did. Good job. So x equals pi plus, I really wanted to put pi, plus pi and NEI. And then we box it because we're proud. Yay. And then this one, sine x equals root 2 over 2 in the middle here. So this is pi over 4 and 3 pi over 4. So x equals pi over 4 plus 2 pi n NEI, so 2 all the way around. And x equals 3 pi over 4 plus 2 pi n NEI. Because we're going all the way around. Could I have done this one as pi over 2 plus 2 pi n NEI and 3 pi over 2 plus 2 pi n NEI? And had 4 solutions? Yep, totally could. So there's my answers. All right. Okay, I'm going to get you to do a proof and then a verify, and then we're going to do some terms and cons. So I want to see if you remember the difference between proof and verify, remember?
Yeah. Use this one.
So I'm going to have you prove.
I don't mind for driving.
So I want you to prove cotan x plus cosecant x over secant x plus 1 equals cotan, and then I want you to verify it for 5 pi over 6. And then what do you think I'm going to also want you to do? MPV, state restrictions. So the first step is to rewrite the equation on both sides, then switch to cos and sine if possible. This one, you have to get a common denominator. Top already has one. So we get cos x plus 1 all over sine x divided by 1 plus cos x over cos x. Then we invert and multiply. We're dividing by. And we get 1 plus cos x, and even though they're out of order, it doesn't matter because cos x plus 1 and 1 plus cos x are the same because their signs are both positive, which is cotan. And then when our images match, we say ls equals rs. Now technically, if we wanted to state NPVs, there were cos x equals 0 and where sine x equals 0. And where 1 plus cos x equals 0, right? Which is just every single 90. So it would be 90, or it would be pi over 2 n NEI. Because you'd have it for sine x, you would have it for cos x, you would have it for 1 plus cos x. 1 plus cos x happens where sine x happens. So our restrictions would be x can't equal 90 degrees n NEI, or pi over 2 if you did it in radians, and it didn't specify. This was in radians, so I would have done it in radians. Pi over 2 n NEI. But they have to specify. All right, verify. The steps of verification are the ones that get done incorrectly. So your first step is to fill in. So you get cotan of 5 pi over 6 plus cosecant of 5 pi over 6 over secant of 5 pi over 6 plus 1 cotan of 5 pi over 6. So that's your 0.5 marked, right? Now guys, if you switch any of these to anything, like if you write it as like cotan of 5 pi over 6, and then the next step it's cos 5 pi over 6 over sine 5 pi over 6, you're done, you get a 0.5. I don't have to even keep marking. Because you're verifying and proving, which you can't do. It's called verify, right? So off to the side, we can find out what every single one of these are, but we need to have a fraction right away or whatever it may be. So if I go off to the side and I want cotan of 5 pi over 6, it's cos over sine, which is negative root 3 over 2 divided by half, I believe, which is negative root 3.
Do you have to show the work on side? Like, are they giving you
No.
a mark for that?
I would, because if I made a mistake, I'd get credit. Yep. Not with anything, but off to the side, for sure. So now I have negative root 3. Cosecant 5 pi over 6 is sine flipped, and sine of 5 pi over 6 is a half, so it would be 2. And then secant of 5 pi over 6 is cos flipped, so it would be negative 2 over root 3. And then if we rationalize it, we get negative 2 root 3 over 3 plus 1. And then cotan we did already, it was negative. Right? This one we need to get a common denominator, so we can turn the 1 into 3 over 3. So we're going to get negative root 3 plus 2, over 1 technically, divided by negative 2 root 3 plus 3 all over 3. And it flips. which looks like it's a far ways away from negative root 3. But it's not as far as that. So it'd be negative, distribute that through, negative 3 root 3 plus 2 root 3 over negative 2 root 3. Well, that's 6. What do I do? 2 times 3 is 6. Plus 6 over negative 2 root 3 plus 6. And then I have to do what? Multiply by the, rationalize the denominator, multiply by 100. So we get negative 2 root 3 minus 3. Negative 2 root 3 minus 3. If you ordered it around, it would just be the opposite. It doesn't matter. Just make sure you switch only the middle. So I would get 6 times 3 minus 9 root 3 plus minus 12 root 3 minus 18 all over negative is 4 times root 3, 3 is 12, so negative 12. Plus 6 root 3 minus 6 root 3 minus 9. So then I get 18 minus, what's the minus or plus? Are they both minuses? Minus 21 minus 18 over negative 21. Root 3. Was it minus root 3 or plus? It was minus, wasn't it? Or minus? Oh, this is a plus, and this is a plus. This is a plus. So it's minus. Wow, just fixed all my world's problems by multiplying a negative and a negative is positive. Perfect. And then LS equals R. Okay. I'm going to give you a word problem. I have $5,000. I don't have $5,000. I have a car that is worth $5,000. And it depreciates. At 15,000. We'll make it a little more pricey, but not really actually a price. No, $15,000 depreciates at 2% per A, which means per what? Annum per year. How many years to the nearest 10? Always make sure we listen to our rounding rules. Will it take for the car to be worth $8,000? That one? And then it's depreciating. And then I want the constant term of 2A plus 1 over A to the 8th. And then I want AX minus Y to the 6th has a term negative 252 XY to the 5. Determine A. F it is. 1 minus. So we have 8,000 is final, 15,000 is initial, 1 minus 0.02. If it was compound interest, remember we have to divide by CP and times by CP. Remember there's that extra one? And if it's doubling, tripling, half-life, the formula is on your formula sheet. It's the only one. And then we're looking for N. We divide that 15. If we know the initial and the final, we'll always divide our initial over first. And so we get 8 over 15 equals 0.98 to the n. And then we convert to convert to a log every single time. So the base of my exponent becomes the base of my log. So I get log 0.98. And then 8 over 15 equals n. And when I plug that in, I get 31.18. And you just round it like normal, unless they ask for, like, has to be below 8,000. Can you just round up? Oh my gosh. Okay, constant term is the term without what? Yeah, without x's or a's or variables, right? So in this case, we have 2a. Remember with these, if there's a minus sign in between, you have to put plus, and the minus joins the y. Remember we turn this as a to the negative 1 into the 8. So we have x, we have y, we have n. So we would have tk plus 1 equals 8ck 2a to the 8 minus k, and then y, which is 8 minus 1 to the k. Now remember I told you if you want to actually figure this out, you can just put it off to the side, or you can plug and chug and see what you can put in for k to get them to actually cancel, correct? Which is going to be 4s in this case. If you don't see that, you could go off to the side and you could say a to the 8 minus k times a to the negative 1k, right? Should equal a to the what? 0. So we get a to the 8 minus 2k, because you add exponents, equals a to the 0. And then you could say 8 minus 2k equals 0, 8 equals 2k, k equals 4. Or you could literally plug in 0, 1, 2, 3, 4 until they actually cancel, if you were completely stuck. So now I have t 4 plus 1. Now if I ask you for the term number, that is the constant, you would say 5, correct? This time I asked you for the constant term, so you actually have to find the whole thing. So you get 8c4, 2a to the 8 minus 4, a minus 1 to the 4. 8c4 is what? 70. And then we have to remember these, distribute through. So 2 to the 4 is actually 16. I don't know, I put in brackets, whatever. A to the 4. Then this is a to the negative 4, and then those cancel, which is what we need. And 70 times 16? 1,000. 5. Okay, this one here says ax minus 1 has a term of this. So we know this is our x. We know this is our y, which has a negative because we have to make a join. This is our n. So we'd go basically 6c box, or k, doesn't matter. Ax to the 6 minus box, and then negative y to the box has to equal negative 252 xy5. Now how does this work? It only works if this is a 5, because this would be y to the 5, this is a 5, then this is a 5. 6c5 should be 6, I believe. And then what we have to remember to do is we have to remember to distribute these to this as well, guys, right? If you distribute it to your numbers in front, 8 to the 1 doesn't really do anything, that's okay. If it was like a 2 or a 3 or a 4, everyone forgetting to distribute that, because you have to square root or cube root at the end, is a common error, right? Forgetting to do that. So this would be a1, x1, negative 1 to the 5, luckily is negative 1, y to the 5. Normally this would be an even number, and then even times a negative would make it positive, so you have to watch yourself, right? And then we get negative 252 xy5, divide by xy5, and I get negative 6a equals negative 252, divide by negative 6, and a equals what?
42.
42. Okay, I'm going to give you the last 2 minutes to go through your tests.